Hello students, welcome to Study Live. Today's concept is free body diagram. See, basically this is not something where you have to write the question answer sort of, right? This is to understand how to solve numericals when there is a pulley attached to string and number of objects are connected. See, as you can see, these are the two diagrams, right? This is the one inclined plane, there is a pulley attached to it, and there is a body which is hang down, and one body which is kept on the inclined plane. Then what are the forces acting on it? So that part we are going to learn here. So both the cases, the diagram as you can see, it is different. Here both masses are kept on inclined plane, okay? So now let us learn the formula for it. Don't have to by heart anything, right? We will understand the concept here. Suppose this is the diagram is asked in the exam and you have to write the formula for it. So what all points you have to remember? As you can see, there are two masses. This is capital M and this is the small m mass, right? Now, of course, what will happen? Over the pulley it is passing. So this body will accelerate downward. So first thing we have to remember is where the acceleration is. So acceleration is this way, right? Downward. So body is accelerating downward. If this is the condition, of course, when there is a string, the tension will act on it. So as you can see, tension is acting on it, and tension always act towards the suspension. Now what is the suspension here? Pulley. Because pulley is the support through which the body is moving, accelerating towards downward. Okay. Now in this case, since the body is accelerating downward and the weight of the body is mg, so this is one force. So of course, since the body is coming here, on the body there are two forces acting, mg and tension, right? So which will be greater, students? Mg will be greater, right? Because body is coming downward. So what the formula we can write here is mg, right, minus t, because two forces are acting in opposite direction, okay? And that will be ma. This is equation number 1. So have you all understood, students, how we get this formula, right? It is very easy to understand. Now look at this object, this mass. Now this mass is accelerating in this way, right? So since this body is kept on an inclined plane, right? Now look at the body. Here, since it is on inclined plane, there are different forces acting, and inclined plane is at an angle theta, right? So the weight of the body is acting downward, right? That is mg, small mg it is written here, right? And of course on the body there will be reaction force which is acting, which is perpendicular to the plane. So that is always there. Now the thing is, this mg will be resolved into two components, okay? One will be opposite to normal reaction, that is reaction force, and the other one will be opposite to tension. As you can see, students, here it is written mg sin theta, and theta attached component will be always cos, okay? So I am going to write here mg cos theta will be the component, okay? So this is mg cos theta component, and of course this component is what? mg sin theta. Now as you can see here, tension is acting towards the pulley and mg sin theta is acting opposite to that. So now can you tell me which will be greater force here? Of course tension, because body is accelerating in upward direction. So I will write the formula here as T minus mg sin theta, right, is equal to which body is accelerated? Small m. So I am going to write ma. Okay. So again this is the second formula. So once you have understood this, how to write it, all the problems will be solved very easily based on this type of diagrams. This part is clear, students? Now let's move on to this part. Here the situation is slightly different. Here two masses, okay, both are on inclined plane. When our body is on inclined plane, we have to resolve, remember, because inclination meaning it is to an angle. As you can see here it is beta, okay. Beta, I hope it is very clear to you all, but again I will write. This is the beta part, okay, and here this is say alpha. Here it is written A, but let me just write here, this is the alpha, okay. These are the two angles to which it is inclined. This is capital M mass, of course that also will be resolved into components, right. Here upward will be always perpendicular to the plane will be what? Normal reaction. So it is reaction force 2 for the second body, reaction force 1 for the first body, correct. Again mass is mg. So students, here it is written small m. So of course it has to be small mg. I can write here, right. And this component, right, that is opposite to the reaction force, since it is to an angle alpha, we can write that part as, so it will be what? mg cos alpha. It will be small m, okay, small m. And of course this component will be, again we can write here mg sin alpha. I have just rewritten that because it is given here capital M, since the body is small m. Here all the components are given very clearly, right students. Now since this body assumed to be heavy, where the acceleration will be? Acceleration will be in this way. And in this part, acceleration will be like this, okay. Looking into this diagram, you can definitely write the formula. See, body is accelerating downward. So which force is more? mg sin beta will be greater than tension, which is there in the string. So what formula students are we going to write here? mg sin beta is greater and opposite direction force is tension, and that will be equal to the force which is acting on a body because of acceleration. So this will be equation number 1, right. Now look at this part. Here body is accelerating upward. So students, which force will be more? Tension will be more, of course, and mg sin alpha will be less. So what will be the equation? Equation will be T minus, here it has to be capital M because mass is capital M, and here mass is small m, so it will be small mg sin alpha, okay, is equal to, so T minus mg sin alpha will be equal to what? Acceleration students, so it will be small m into a. So this is equation number 2. So this is how we have written equation of that part, right. So here is it very clear? So if this type of diagram comes, these two formulae if you remember, it is very easy to solve. In fact, you don't have to remember, you can directly understand from here, right. So I hope students you have understood the concept, and with this, like this, we can have some more free body diagrams which I am going to explain how to write in short the equations, okay. So stay with Study Life, and thank you so much.